Hello friends, welcome to Circuit Adda. Today we are back with a new tutorial in which we are going to do a small project, right? So the name of the project is RFID Door Lock Access Control System. So before moving into this, what we are going to do, if you want to know more about the Arduino and all other technologies, do subscribe our channel to get more exciting content. So now let us move into the video, right? So what is an RFID? So I had already explained you in our previous tutorial how we can interface an RFID with an Arduino board, and I had also explained you how to interface an LCD display with an Arduino board, right? And today what we are doing here is we are trying to interface both the RFID and the LCD with an Arduino board, right? So you can see this is our LCD, okay? This is our 16 by 2 LCD, and this is our RFID, okay? RC522 RFID, okay? And this is our Arduino board. So in our today's tutorial, this is a small project because now we have moved into our advanced level, right? So we are going to do the small projects by combining all the knowledge that we had gained from the previous tutorials, right? So today the project that we are doing is, I had named it as RFID Door Lock Access System. That means we are going to we are going to make an access system for a door, okay? So I am not going to show you how we are door is getting open, but I am going to make you know how we are going to make an access control system. That means we are having an RFID tags, right? So what we will do, we will make these tags authorized. Okay, so I am going to take two tags today. One will be the valid tag and other will be the invalid one. Okay, other will be the invalid one. So whenever the user places the tag upon this sensor, so on the display it will show whether it is an access is denied or whether access is granted. So if the tag that we place near to the RFID is a valid tag, then my LCD display will show a message that access is granted. So the access will be granted only to those RFID tags which are valid according to our system. And if we are going to place some other RFID which is not valid, then the LCD display is going to show that access is denied. So it will be a access system, right? That means with a RFID we are going to access something, and our system is going to take the RFID tag and it is going to identify whether the tag is valid or not. If the tag is valid, then we can see a message on our LCD display that the tag is an valid. We can see a message here that the access has been granted because the tag is valid. If the tag is invalid, then it will show a message that access is denied because you are not a valid user for according to my database, right? So now let us move into the connection here. I am not going to explain you about the RFID or LCD display here because we had the separate tutorial on RFID, right? We have a separate tutorial on RFID and a separate tutorial on an LCD. So if you want to go through that, I will provide the description both for the RFID tutorial and LCD tutorial in the description. Okay, the link for both the tutorials will be provided in description. If you want to know about them, you can go to the description and know everything. Today we are directly moving into the project, right? So this is our circuit diagram, okay, but I am going to explain you the circuit diagram so that you can recall the previous tutorials, right? So you know that our RFID will be working on a 3.3 volt supply and our LCD is going to work on a 5 volt supply, okay? So in this tutorial we are going to use both the 3.3 volt pin and 5 volt pin of our Arduino, right? So let us see. This is our V-in pin. So we had connected the V-in of our RFID to the 3.3 volt supply, okay, and the ground of RFID is connected to the ground here, and this is our do you remember what this pin is? So this is our reset pin, right? So we are connecting our RFID reset pin to our 9th pin here, okay, and then we are having MISO and MOSI, right? So we are connecting our MIS4, this one, right? So this is MIS4, so we are connecting our MIS4 to our 12th pin and MOSI to our 13th pin. As I had explained to you that this is going to work using a SPI protocol, right? SPI means SPI is going to have a master in slave out and master out slave in pins. So the MIS4 pin will be connected to the 12th pin of the Arduino, because the 12th pin of the Arduino is dedicated to MIS4 and 13th pin of the Arduino is dedicated for MOSI, right? And then the last one here, it is an these two are the SCK and SDA. So we are connecting the SCK and SDK to the SC and SDK of our Arduino board. Okay, so the connection is same as that we had done in our RFID tutorial, right? So VIN will be connected to 3.3 volts pin of the Arduino, and the ground will be connected to ground of the Arduino, right? So the ground will be, I think, here somewhere, right? The ground will be, right? So the ground will be connected to ground of the Arduino, and then the MIS4, this which one we can call the MIS4. So the MIS4 will be connected to our 12th pin, and MOSI will be connected to our 11th pin, and then the SCK will be connected to 13th pin, and the SDA will be connected to the 10th pin of the Arduino. So this is our connection. Okay, you can get the connection in our previous, the connection is same. Okay, and coming on to the LCD display, I had explained you that the VSS here will be the ground. Okay, so the LCD's ground will be connected to ground of the Arduino, and LCC supply will be connected to supply of the Arduino, and we are going to take, for the LCD we are using the 5 volts pin of the Arduino, but for the RFID we are using the 3.3 volts pin of the Arduino, because this is a 3.3 volts pin module and this is a 5 volts module. Okay, and then there is a V0 for adjusting the brightness of the LCD. So for the V0 we are providing the supply through a potentiometer here. Okay, so by varying the potentiometer we can vary the brightness of the display, right? And then the RW pin, this particular RW pin will be ground, because I had explained you that RW means read and write pin. So if you are making it 1, then the LCD will work in a read mode. The whatever the command that is getting on LCD, it will be read by the Arduino. But when we are giving 0 to the RW pin, then the LCD is going to work in a write mode. That means whatever the Arduino gives, that message will be displayed on our LCD display, right? And then here it is an A and K. The A will be anode and K will be the cathode. So anode will be connected to the 5 volts pin, but through an 220 ohm resistor. Okay, and the cathode will be directly connected to the ground of the Arduino. And these 4 are our pins. As I explained to you in our previous tutorials, so LCD have 8 pins for data. Whatever the message that the LCD want to display on the LCD, that message will be transmitted to any 8 pins of the 8 data pins of the LCD. So here I am using the last 4 pins, that means D4, D5, D6 and D7, and these will be connected to any 4 digital pins of our Arduino. So here I am using the 2nd, 3rd, 4th and 5th digital pins of our Arduino and connecting it to an LCD here. Okay, so the connections are very similar as we had done in the previous, right? So the here I am again repeating that here the RFID needs a 3.3 volt supply. So the VCC of this module will be connected to 3.3 volts pin of the Arduino, and the LCD needs a 5 volt supply. So the VCC or VDD, whatever may be, I had explained you that in some modules it will be VCC and in some modules it will be VDD. So whatever may be, it will be connected to 5 volts pin of the Arduino, and this needs an MISO, the SPI protocol. So you have to find out the SPI pins of the Arduino, and in the SPI pins, one will be SCK, one will be SDA, one will be MISO and one will be MOSI. So depending upon that, we will connect them to this. And the LCD pins are, the data pins will be connected to any 4 or 8. You can use all the data pins or you can use any 4. In my, I am using the 4 data pins. Okay. So the connection is as we had done in our previous tutorials. If you are getting some confused, so you can go through RFID's tutorial separately, and you can go through the LCD modules tutorial separately, and after that you have to combine the both to make this project. Okay, so now let us move to the coding part, because the complete connection diagram is very simple here. So let us move to the coding part here. Okay, so this is our code for today's project, which we can call it an door access control system, right? So as I had said to you, we are having an RFID here, RFID module. So the RFID module will communicate using the SPI protocol. So first we have to include the SPI library, and then we have to include the library of RFID. So I am including the library of RC522 RFID, and then I am including the library of our LCD display. And then after including these three libraries, one library is for SPI communication, one library is for RFID module, and one library is for our LCD display here, right? So now let us define the pins. Okay, so I had connected my LCD's reset pin to the 9th pin of the Arduino, right? And then I had connected the SCC pin to the 10th pin of my Arduino. Okay, so I had defined those pins, and then I had defined a word which is a 4-word byte, because it will take the card data here. Okay, and then I am taking another variable with the name of master tag. So what is this master tag? Here I am authorizing the cards. So the card ID that I am authorizing today is having a ID of 17F02F83. So this is the tag ID. Okay, so whenever we are going to place the tag upon our RFID, if that particular tag is having this ID, then only we are going to get the access. The access will be granted. If the tag that I am placing here to my RFID is not having this ID, then the tag will be rejected, right? So if you want, you can replace it with your RFID tag. So I have two RFIDs with me. So one of my RFID is having this tag. So I have given the tag ID of that RFID here. Okay. So you can change it and replace it with your RFID tag. Okay. So, and then a string which will carry this is our master tag. So we are going to compare the RFID tag that we placed upon our module with this master tag, and if both the matches, then we are going to grant the access, otherwise we are going to deny the access. Okay, so and the below one, this one, tag ID, this will carry the real-time tag ID of the tag that we are placing upon our RFID module. Okay, and then before moving into the voice setup, we are starting two objects. One object is for our RFID to initialize the RFID, and other object is for our LCD crystal to initiate LCD crystal. So the pattern here I had explained you in the previous LCD tutorial. So first we are going to write the RF pin, with digital pins number to which the RF pin of the LCD has been connected. So my LCD, the RF pin has been connected to D7, so here 7, and then my enable pin of my LCD has been connected to 6th pin of Arduino, so here 6, and then my D4 of my LCD has been connected to 50 pin of Arduino, so 5, and then 4, and then 3, and then 2. So it depends upon you. If you have connected the RS of your LCD module to 8th pin, then you have to write 8 here. So whatever the pins, the sequence has been given here in the code for your simplicity. So first write the pin number of the RS, and then enable pins number, and then data pins numbers. Okay. So now let us move to the voice setup here. So what we are going to do in the voice setup. So first we are going to begin the SPI, because our RFID is going to use the SPI protocol. So the first thing that we need to do is we have to begin the SPI communication here. Okay, after beginning SPI communication, we have to initialize the RFID, and then we have to begin the LCD module, and here we have to mention our LCD module size. So my LCD module is going to have 16 columns and 2 rows, because my LCD is a 16 by 2 LCD. So I have written 16 by 2. If you are having 32 rows and 4 columns, then 32 columns and 4 rows, then represent the particular number here. But today's my LCD is having 16 columns and 2 rows. So that's why 16 comma 2. Okay. And after that, once the Arduino starts, whatever the data message that is getting displayed on LCD, that should be cleared here. Okay. And after that, we have to print a line with a message of access control, because our project's name is access control. So it will display a message access control. Okay. So as I have not mentioned any cursor position here, so this access control will be displayed on the first row of my LCD. Okay. And then I had when I want to display my second message, as we had discussed in our LCD's tutorial. So we have to define the cursor position, because already the first row has been occupied by this access control message. So now we have to start the second message in the second row. So here I have defined the position as 0, 1. 0 means first column and 1 means the second row, because the numbering will start from 0. So 0 means the first column and 1 means second row. So it will start from the second rows, and the message that will be displayed on my second row is scan your code. So the first message, whenever the Arduino starts, the first message that will display is access control, and below the access control, scan your code will be displayed here. Okay. And now let us move to the void loop. Okay. The first function that work in the void loop is get ID. So what is this get ID? So this is a custom function. It is not a function in our library, and this custom function has been defined at the bottom here. It is a boolean function, boolean get ID, and the inside code has been written here. So what here written is, it will take the RFID's number and it will convert it into a series of strings, so that it will be understandable by our Arduino board. Okay. So first it will get the ID. Okay. Once it gets the ID, so what it will do, it will clear the LCD. It will set the cursor to the initial position, that is 0, 0, the first row's first column. Okay. Once it first it will check for the ID, and if the RFID tag is placed near to my sensor, then it will get the ID of the tag. Once it gets the ID, the first thing that it will do is, it will clear the LCD display, and after that it will set the cursor to the first row and the first column, that means the starting of the display. Okay. After that it will compare the ID of the tag that has been placed upon our RFID module with the master tag that I had already saved in my code. Okay. So let us consider I am placing one tag on my RFID module. So whatever the ID of the tag, so that tag's ID will be compared with the master ID that has been written in my code. Okay. And if the both matches, that's why I written tag ID is equal to master tag. That means if the ID of the tag that has been placed on my RF module is equal to the master tag that has been saved in my code. The master tag is here, this one. Okay. 17F02F83. If it is matches with the 17F02F83, then the LCD display will print a message, access is granted, because the tag ID that has the ID of the tag that has been placed on my RF module matches with the master tag that has been written in the code. So if it matches, then it will show a message, access granted. So because it is a valid tag, so the access has been granted. Else, if it is not equal, then a message will be printed on the LCD that access has been denied. Okay, access is denied. Why? Because the ID of the tag that I placed on the module does not matches with my master tag that has been saved in my Arduino. Okay, so very simple one. First we are getting the ID. If any tag has been placed on my module, and if the module gets the ID of the tag, so first the LCD will be cleared, and then the cursor will be set to the topmost position, and then whatever the ID that I have got from the tag, that ID will be compared with the master ID that has been saved in my code. And if the ID of the tag that placed on my module matches with my master ID, then the LCD will print the command that access has been granted. If the ID of the tag that placed on my module does not matches with my master ID that has been stored in the code, then it will show a command that access has been denied. Okay, very simple thing. We are comparing the ID of the tag placed on the module with our master tag saved in the code. Both matches, access will be denied. If the ID tag does not matches with my master tag, then access will be denied, right? So what we will do, we will connect our Arduino board, and then let us dump this code or upload this code in our Arduino board. So let's go to tools and check. Yes, the COM15 is working here. Okay. So now let me upload the code here. So let us wait for the code to get uploaded. So I think the code has been uploaded here, right? The done uploading. So now let me open the camera and show you whether my IE project is working properly or not, right? So you can see on the screen here. So this is my complete module. So this is my Arduino board. Okay, this is my LCD display, and this is my RFID. module, right? So you can see on the LCD display, it is showing access control scan your code, because I have not placed any scan on my ID, so it is showing to scan your code. Okay, so now what I will do, I will place one tag upon that. Okay, so you can see here, this is my tag. Okay, so I am placing this tag near to my module, so you can see that access has been denied. Why? It is showing a message. You can see on the display here, when I bring this tag, okay, when I bring this tag near to my module, so access has been denied. And why it has been denied? ID of this tag, this particular tag's ID has been shown in the display. You can see that also. Access has been denied because my tag's ID is 33. You can see tag ID is 33F62F83. Okay, again let me try again. Again it is denying because my tag ID is different from the tag ID that has been saved in my code. So now let us place the actual tag here. So this is my actual tag, access granted, because ID matches with my master ID. Okay, so you can see this tag has been rejected, okay, and this tag has been accepted. Okay, because this tag's ID has been saved in my code. Okay, this tag ID has been saved in my code, and this tag ID has not been saved in my code. So this tag is an invalid tag and this tag is a valid tag. So let me check again. I am placing one tag, access denied, because this is an invalid tag, so keep that far from that. So now I am placing this tag, so access has been cleaned, that this is because this is a valid tag here. Okay, so this is how we can make a door access system. So now I just show you a here. Okay, I have just shown you a small example of that. So when I place proper valid tag, it is accessing, giving a grant access, otherwise it is denying the access grant. Okay, so this is what today. And if you want to know, if you like our today's project, please hit on the like button, and if you want to know more content about the Arduino and other things, do subscribe our channel. Thanks for watching the video. Keep learning.